So we're going to start on the back side of this guided notes today. And we're going to focus our attention at the beginning here on right triangle trig. So my geometry students are actually learning this right now. We just started this on Tuesday. And I'm going to take you through here in the next 20 minutes what my geometry students are going to be spending like 2 weeks on. Okay. But they've never seen this before. They've never heard of sine, cosine, and tangent before this. So you guys have at least seen it. So you got this. Okay. But it is going to be fast. So you need to be honest with yourself. If you're not getting this stuff, it is something, give me an opportunity to help you get caught up. But this is all the time we can afford in class for it. All right, I recommend, unless you're a pro, go and write your cheat code up here. Our first step when we're solving for pieces of triangles is to identify the angle that we're going to be using, and then to label our sides. And I'm forcing my geometry students to label all 3 sides. I'll let you guys decide whether you would want to label all 3 sides or just 2 for right now. You will get to a point where you won't even label sides. You'll just go straight to the equation. But if you're not there yet, take the time to do this, okay? Because it's easy to mix up. So I tell my geometry students always go for the hypotenuse first. It's the easiest to spot because it's across from the 90. Your 2 other sides are opposite and adjacent, and it's relative to this angle. So if you imagine yourself sitting at this angle and looking across the triangle, the side opposite you, we're going to label with O for opposite. And if you're sitting at that angle, the side that's right next to you is the adjacent. My geometry students right now are making the classic mistake where they call this the adjacent side because they're like, it's right next to the angle, which is true, isn't it? But it's not, because it's the hypotenuse. The hypotenuse is the hypotenuse. This is why I tell them always label the hypotenuse first, and then you won't have to make that mistake, right? So can I get you guys to really quickly go ahead and label your sides for these other 2 triangles relative to the angles that are marked here? All right, so first step is to label your triangle, figure out which side you're dealing with. Our second step is we need to choose which trig function we're going to use. Are we going to use sine or cosine or tangent? To do this, we have to pick the 2 sides that we have information from. Now, sometimes you've got options. If you have information about all 3 sides, you only need 2 of them. In this case, we only have information about 2 of our sides. So we're stuck with O and H. The one that has O and H is sine. So I'm going to go ahead and write a sine equation. It's going to look a lot like that last one that we did. Angle always goes in the parentheses. And remember, SOHCAHTOA is how you tell what side goes on the top and the bottom. The first letter on the top, second letter on the bottom. So O on the top, hypotenuse on the bottom, we get that equation. All right, if you would please, can you write me, don't worry about solving this just yet. Hold off on solving. We're going to show you the 3 methods here in a moment. Could you go ahead and just write me equations for the other 2 triangles? Do those next 2 steps on your own. Identify which sides you have and pick your trig function, and then write the equation. All right. We feeling good? Are you matching my equations? Did anybody flip any fractions? Oh, come on. Somebody flips some fractions. It's all right. I have written and solved at least thousands of trig equations in my math career, if not tens of thousands. And I still flip fractions about 5 or 10% of the time that I write an equation. About 5 or 10% of the time I'll flip a fraction. However, I double check 100% of the time, and I usually catch that mistake before I go on. So do double check because it's super easy to do. All right, any questions up to here? So if I gave you a test right now, just writing equations for triangles, do you guys feel like you could ace it right now? Or at least like maybe with a little bit of practice. We feeling good? Okay, now solving these. There's the mathematical way and then there's the math-magical way. Are you guys okay with a little bit of trickery and shortcuts? Yes? Okay. I don't show this to my geometry students. I want you to know why these things work. You really should know why these shortcuts work. But I'm going to show you the shortcuts because this needs to be something that we can do pretty quickly. All right, so there are basically 3 styles of equations, and I designed this so that we would see one of each. Not so much based on the sine, cosine, or the tangent, but based on where your variable is. There's 3 places it can end up. It can end up in your numerator, your fraction. It can end up in the denominator, your fraction, or it can end up as the angle. Those are the 3 spots your variable can be. And the way you solve the equation differs depending on where it is, the shortcut that you use, okay? So my shortcut for variable on the top, well, this one's pretty easy, right? We just solved one of these. You're going to multiply on both sides by 7. The shortcut that I think of is I just bring that 7 over to the spot in front. And you end up with the equation 7 sine 37 equals x. And we would type that into our calculator. Okay, so that's the easy one. This is when the variable's in the top, usually people are like, yeah, I just multiply 3 by 7. Got this. Okay, that's that shortcut. This one, the next one, when the variable's in the bottom. Oh, let's go ahead and do this, by the way. Let's do 2 decimals places. Oh, this is 10, 1 decimal place. 7, 7. That's really close to the last thing. 4.2-ish. All right, variable on the bottom. This is definitely some mathematical trickery here. Okay, it works though. In this case, I'm going to take this x that's in the bottom, and I'm going to take this whole side of the equation and I'm going to flip-flop it. My equation is going to become x equals 3 divided by cosine 54. And then I just type that into my calculator, 3 divided by cosine 54. And I'm getting about 5.1. All right. So far, so good. All right, last shortcut. When the variable is locked up inside of the trig function, the way we technically get this out of here is we use an inverse trig function, right? Because an inverse cancels it. Remember when we did inverses before, we said if we took the inverse and the actual function, we put them inside each other, we just get x out of it. So that's what we're going to do here. The shortcut is, instead of, well, what I'm really doing is I'm taking an inverse tangent on both sides. I don't usually write this step down, but I'm taking an inverse tangent of this whole thing. And I'm also taking an inverse tangent of this whole thing. My shortcut would be the theta stays, and we end up doing an inverse tangent of it. So this isn't so much of a shortcut. This is really what we are doing, is taking an inverse tangent on both sides. My shortcut is that I just don't usually write this step down. I just kind of think through like, oh, inverse tangent is going to cancel this off. Then I got to do it over here too. And then that goes into our calculator. And you guys know how to find your inverse trig functions on your calculator. It's the second function for each of them. So second tangent. That gets us the tan with the little -1. And then inside your parentheses, put your fraction. Oops. And I'm getting about 22.4. 22.4 what? This is an angle. 22.4 what? Radians or degrees? How do you know it's degrees? Is it too big for radians? Yeah, that's maybe. What mode is our calculator in? If it's in degree mode, then it's in degrees. Okay, when you set that mode, you're setting what type of angle you get out of your distribution. So if I wanted this angle in radians, I could do that. Go into my mode, change it to radians, and then just type the same thing in again. I'm going to get a different answer because now it's showing me my answer in radians instead of degrees. Okay, switch back to degrees. All right, let's have a little race. What do you think? Anybody want to challenge me? I require that at the minimum that you write down your equation and write down your answer to the nearest step. Okay. You don't have to show other steps other than that. I recommend, especially if you're feeling a little fuzzy on this, I recommend that you do label your sides. I'm going to give you guys a few minutes to work on this. Whatever you don't finish will become homework. Okay. And let me work these out so you can check your answers as you go and ask me questions after that. Give a little head start.